Okay, limiting reactants and percent yield. So the limiting reactant, it is the reactant that determines the amount of product we will have. And the excess reactant is what's left over. Anytime we have a reaction, we normally have one component, one of our reactants is in excess. So we have more of it than we need, and that just helps make sure that our reaction goes to completion and that we get all of what we want. So to predict which one is the limiting and which one is the excess, then we need to figure out how many moles of our product is produced. So to do this is we're going back to that stoichiometry we've been working on for the last month or two. If I have 50 grams of hydrogen, 50 grams of hydrogen, then I need to find out how many moles of water are produced. So 50 grams of hydrogen, I need to convert that to moles of hydrogen. So 50 grams, there's 2 hydrogens, so 2 times 1 is 2. 2 grams of hydrogen is the molar mass to 1 mole. Then I'm converting 1 mole, or converting that to moles of H2O. So in the water we have 2 H2s to 2 H2Os. So 50 divided by 2 is 25, times 2 is 50, divided by 2 is 25, so 25. So we would produce 25 moles of H2O. Now O2, and I do this a little bit differently when I'm doing it myself. This is the method I've shown y'all, and I believe I've shown you this other method as well. I tend to add kind of an extra step when I do it because it's just how my brain works. Um, and it might be easier for you. As I talked through this, I talked about the steps. But here, so let's do 50 grams of oxygen. So we have 50 grams of oxygen. We need to convert that to moles of oxygen. So 1 mole of O2, and oxygen is 16 grams times 2 should be 32. And that should equal 1.56 moles of oxygen. So now I need to convert my moles of oxygen to moles of water. So I take that 1.56 times moles of O2 is 1. Moles of water is 2. So 1.56 times 2 is 3.1 moles of water. So if you notice, the only thing that's different is I put an equals after the first step. Otherwise, everything's the same. I just have a tendency to break it down and think through it step by step. So 3.1 moles of water. So which one produced the least? Hydrogen produced 25 and oxygen produced 3.1. So oxygen is our limiting reactant because it produced the least. And hydrogen is our excess. It is the one I'm going to have leftovers of. And I'm going to have a lot of leftovers in this case. And if you want to find out how to figure out how much excess I have, it would be 25 minus 3.1 would be 21.9 moles. And so then you could convert that 21.9 moles to grams. Okay, so percent yield in the laboratory, we never wind up with exactly what we're expecting. We always wind up with less. You should not ever wind up with more. That means when you're measuring your reactants, you measured something wrong. So our percent yield, we take the actual amount from our experiment, the amount from our experiment, divide it by our predicted amount or our theoretical amount times 100%. So if we actually produced 45 grams of water, what is the percent yield? So we need to, we said in the previous, on the previous slide that we had 3.1 moles of water. So I need to convert that to grams of water. Let's see, H and oxygen, 2 times 1, 1 times 16. So 18 grams. So 1 mole of H2O is equal to 16 grams of H2O. So 3.1 times 16, I believe is 55. 55.8, I believe. 3.1 times 16. 3.1 times 16. 49.6. Oh, 18. That's why. 18 times 3.1 is 54. 55.8. So we take our experimental, which was 45 grams, divide it by our theoretical, and we get 80.1 times 100 is 80.6%. Now, anything over 80% is considered good, particularly in a high school lab or a college beginning chemistry lab. Anything above 90 is awesome. Um, just know that we don't have the equipment usually to get anything above 80%, but 80% is usually considered really, really good. If you have any questions, let me know. Thank you.